கொஞ்சம் டிஸ்டர்ப் பண்ணிடாதீங்க. செஷன் வேற காலேஜ் செஷன் போனாங்க. இல்ல யதார்த்தமா எப்பவும் போல கேஷுவலா வந்து சத்தம் போட்டுறாதீங்கன்னு ஸ்டார்ட் பண்ணிட்டு இருக்காங்க தான்.
Hello ma'am, video and audio check பண்ணிக்கலாம் ma'am. There is a screen sharing check பண்ணிக்கலாமா ma'am?
ஓகே மேம், உங்களுக்கு எல்லாம் தெரியுதான்னு பாருங்க. இப்போ நான் பேசுறது கேக்குதுல்ல?
Yes ma'am, it's audible. Then அப்பனா no issues தான் நினைக்கிறேன். கொஞ்சம் participants இப்பதான் நம்ம கனெக்ட் பண்ணிட்டு இருக்கோம். ஒரு 5 to 10 minutes வெயிட் பண்ணிட்டு then we will start the session ma'am.
ஓகேங்க மேம். வீடியோ தெரியுதுங்களா இல்ல உங்களுக்கு வீடியோ வேணுமா இல்ல க்ளோஸ்
பண்ணிடலாமா? Yes ma'am. அது வந்து உங்களோட சாய்ஸ் தான் மேம்.
சரிங்க மேம், ஓகே. நான் கொஞ்ச நேரம் ஸ்டார்ட் பண்ணும்போது மட்டும் இருக்கட்டும், அதுக்கப்புறம் நம்ம க்ளோஸ் பண்ணிக்கலாம்.
ஓகே மேம், ஓகே மேம், தேங்க்ஸ்.
மேம், இப்போ நான் ஸ்கிரீன் ஷேர் பண்றேன், விசிபிளா இருக்கான்னு மட்டும் ஒரு டைம் செக் பண்ணிக்கோங்க. ஹலோ மேம்.
ஓகே மேம்.
அப்படியே கூப்பிடுவோம் மதிய.
மேம் விசிபிளா இருக்குங்களா?
Yes ma'am, it's visible ma'am. Okay ma'am, visible.
Okay ma'am.
Okay ma'am, thanks ma'am. So within 5 to 10 minutes நம்ம session start பண்ணிடலாம் ma'am.
Okay ma'am.
Okay ma'am, thank you ma'am.
Good afternoon, everyone. It's the third phase of day 4. So the session topic is on machine learning using Python, which is going to be presented by speaker Dr. R. Devi Priya ma'am. I thank our institution and our CEO, Sri Sairam sir, for arranging this series. And also, I want to thank AICTE for sponsoring this series. I want to thank our principal, Dr. K. Paranikumar sir, event coordinator, Dr. B. Sridevi ma'am, HOD Department of CSE, even co-coordinators, Mr. Jayachandran sir and Mrs. Rajalakshmi ma'am, for making your presence in this session. So without any further delay, let me introduce our speaker of this session, Dr. R. Devi Priya ma'am. Dr. R. Devi Priya ma'am is an associate professor from Department of Information and Technology, Kungu Engineering College, Erode. Her field of interests are data warehouse, big data, and so on. Moreover, she has 11 plus years of experience in teaching, and also she has published 3 books, 39 journals, and 11 conferences. And also, she has received Best Faculty Award and also secured University rank in IME degree. We are extremely privileged to have you, ma'am. So I request our speaker, Dr. R. Devi Priya ma'am, to take over the session. Please, ma'am.
Thank you, sir. Good afternoon, everybody. Good afternoon.
Good afternoon, ma'am.
Yes, sir. Sir, am I audible? Yes.
Yes, ma'am.
Okay, sir. Actually, now we are going to see how to use machine learning using Python. I think in the previous session. Hello. I think in the previous sessions, you have covered about machine learning, different types of machine learning. Yes. In the morning session also, I think the classification and clustering algorithms, the basic machine learning algorithms are taught. Yes, sir?
Yes, ma'am.
Yes, sir?
One second, ma'am. Participants are mute பண்ணிடுறேன், ma'am. 1 second. மேம் நீங்க மியூட் எடுத்துட்டு நீங்க தென் அன்மியூட் பண்ணிட்டு நீங்க டெலிவர் பண்ணுங்க மேம். ஓகே மேம்.
Ma'am, morning session you have covered a detailed explanation of
morning session
classification.
I have covered machine learning machine learning with the Vega tool.
Vega tool, ma'am. Ma'am, now I just want to give
So
a
clustering classification, yes, ma'am.
Yes, ma'am. You have
Yes,
got an idea about what is the basic principle behind classification? Yes or no, ma'am? So that I can skip the topic and go to the next one.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, ma'am. Thank you.
Yes, ma'am. Yes, ma'am.
Okay, ma'am.
So you just skip the topic, then you move on to the next topic, ma'am.
Okay.
Okay.
Okay, ma'am. Thank you. Okay, just to have a brief overview, we'll see what are the different types of machine learning algorithms. I hope you all remember all those things. Just want to have a small recap. There are 3 different types actually: supervised learning, unsupervised learning, and semi-supervised learning. And can anybody tell which type of learning method is classification and clustering? Can anybody tell? Yes. I think it's afternoon after the heavy lunch. Is anybody can tell what is meant by classification and clustering and how it is related to these methods? Which category classification will be and which type of learning will be clustering? Okay, let me continue. So actually classification comes under supervised learning where you have the labeled examples. Yes, I'm just giving a simple real world example of how classification and clustering will be, where suppose if you have some kind of mixed people in a classroom in the sense, or in a group, if you want to categorize them based on gender. For example, if you are asking them to group among themselves based on their gender, means male will come and sit in one category, one side, and female set of people will sit in another category. Yes, here in this case, you know how many number of examples are there, how many number of labels are there. So here we have defined two categories. Yes, male and female are the class labels. Here we are going to perform classification. So the number of labels are already known, and also the characteristic of each label is known. Yes, that is why it is given as trained on labeled examples. Trained on labeled examples. The labels are already known, and it attempts to generalize a function for mapping input to output. Yes, you have some inputs to be fed to the supervised learning algorithm, and you will get the classification of them. And unsupervised learning is nothing but you don't have any predefined labels. Yes, you just ask them to group among themselves. You do not specify how they are going to group based on gender, or the characteristics which distinguishes them is not told explicitly. Based on the similarity between the objects they identify, they group among themselves. That's the basic idea behind unsupervised learning. And semi-supervised learning, where you have some labeled examples and some class labels will be unlabeled. Yes, okay, let us not waste time on this. Okay, so this is a simple example where if you are given some images to any machine learning algorithm, it will be confused whether to classify it as an object A or object B, because in the example given here, see here, all the images look almost similar. So we are able to find difference between these dog and fried chicken. So it's a little bit difficult, right? Both looks same in some cases. And again, this example also, the face of Trump and the raw chicken looks almost similar. So we find it very difficult to distinguish between the two set of images manually. Imagine how the machine learning algorithm finds it difficult. So again, we should train our algorithm in such a way that these are distinguished and classified properly, not only with images. This case is with any other kinds of inputs also. It may be a text document, or it may be a database, or it may be an image, it may be an audio, or it may be any unstructured data also. We want to classify based on the features. Yes, okay. In supervised learning, you know the concept, but I just want to tell the what are the types of variables that you have to perform classification. We have many machine learning algorithms, and for this session we are going to see only one classification algorithm. Okay, so we are going to see support vector machine in Python, and how this algorithm can be implemented in Python. Yes, normally whenever you are using some variables, you have these types. Either it can be a categorical variable where the variables will have finite set of values. For example, gender. It may have either male or female. Color, red, green, blue, or yellow. Department in a college. Okay, so computer science, IT, mechanical, ECE, likewise, and multi-label. Actually, binary means we have only two class labels for an attribute. What is meant by class attribute actually? Because before implementing any ML algorithm, we should understand the basic meaning of the terms that we are using. Okay, so what do you mean by base? What do you mean by binary variable? The class variable which has two class labels. For example, gender, two labels. Multi-class variable means it has multiple class labels, red, green, blue, or departments, computer science, IT, EC. Multi-label means for a single record, it may be associated with multiple labels. Okay, that we will see. For example, class A, the record 1 may come record 1 may come under class A and also class B. Okay, both are present for this particular record. That is called as multi-label. And we have real valued variables where they have only continuous values. For example, age, salary. It has continuous values, and the methods applied can be simple regression or multiple regression. Okay, that's continuous values. For example, salary, you have infinite number of values accepted for that attribute. Yes, ranging from ₹1 to 1 crore or 5 crores. It can have infinite number of values. And next one, ordinal. Ordinal is nothing but the categorical attributes which have ordered among them. For example, you have the class labels categorized as income equal to low, medium, high, very high. So this is called as ordinal, where some ordering is maintained between the attributes. And next you have ranking, where ranks will be assigned to the attribute labels based on some criteria that you are fixing. And at the last, you have some structured output, where the output may be sequence or tree or graph. If you are using decision tree classifier, the output will be in the form of decision tree. Sometimes it will be graph. So these are the outputs of any classification algorithm. Okay, and we will be having two types of sets, training set and testing set. Yes, yeah, if you know, we'll skip this. Whenever you're having a data set, you have to divide the data set into two. For training the model, you will provide the training set where both inputs and outputs are available. And after training, you will get some model, and using that model, you will provide the test set for evaluation. And the number of samples which are classified right or wrong will be accounted for your classification accuracy. And in testing set, only inputs will be available and you will not have any output. Okay, you provide input, the algorithm extracts features, perform classification, and it says whether it's a car or not car. So what is the type of attribute here? It's a categorical attribute where you have two class labels. Okay, car, not car. This is a binary categorical attribute. And this is a supervised learning structure. One example where if it is a text document, you want to classify.
Ma'am, excuse me, ma'am.
Yes, sir.
Please don't mind, ma'am. Can you repeat once again previous slide, ma'am?
Previous
that
slide.
Category.
Categorical, sir. Okay.
Yes.
Okay, sir. If you have an attribute, for example, gender, what are the possible values for gender? You may have either male or female, or the third case, transgender. Yes, sir. So if you have only finite set of possible values for an attribute, that can be called as a categorical attribute. If you have two values, see this example, you are having car, not car. You only two, is it car, is the class attribute. Class attribute is nothing but the final decision attribute for which you are going to perform classification. For example, if you want, the manager of a bank wants to decide whether to grant loan for a person or not. Okay, so how will he decide? The final class attribute, that means decision attribute, is nothing but grant loan. Grant loan is the attribute. You can have either value yes or no. Yes, sir? Yes or no. Yes is one class label and no is another class label. Here also, is it car? Car means yes is one class label, not car is another class label. If you have only these limited number of class labels, it is called as categorical. If two, it is binary. And if you have 4 or 5, for example, number of departments in a college, it may be up to 10 or something around that. Where it is limited, that means you can categorize them into groups. That is categorical. Yes, sir. Is it clear?
Yes, ma'am. Yes, ma'am. Thank you.
Okay, sir. Is there any doubt in this slide, sir, or I can move forward?
No, ma'am. Move. It's okay, ma'am. Thank you.
Okay, sir. Thank you. And this is an example of supervised learning for a text classification, where you have text documents, or it may be images or sounds. You are going to give input text documents and it will extract the feature vectors. The main important concept in classification is it has to extract features select for a classification, because in a data set normally you will have n number of features. For some large data sets, for some medical data sets, you may have up to 50 attributes for performing classification or clustering, whatever may be the operation. But for doing some classification, you may not use all the attributes. Suppose if you need only 5 attributes, which are very crucial for your current analysis, you have to extract these 5 features or 5 attributes. Features or attributes or vectors all mean the same. Okay, how to extract these 5 features? How to extract 5 attributes out of the available 50 attributes is the given problem. So, and again, there are many feature selection algorithms for selecting the significant or very relevant features. Okay, that is not covered here, but please remember that you can have separate research. If you want to perform a research or do PhD, you can propose a new feature selection algorithm. That's a very highly common research area. And the feature vectors are selected and you are giving to a machine learning algorithm, and the class labels of the target attribute or class attributes are also set. Here it's a classification. So we have predefined labels. The labels are already known. So you are providing the labels. Yes, gender, male or female. If you want to predict the particular patient has cancer or not, has cancer is the final decision attribute, and you may have yes or no. Yes, that label and characteristic of each label can be given here to the machine learning algorithm. Now the predictive model is ready. What you have to do next, you have to give the text document, test set. If you have 100 records, for example, in your data set, you will divide it into two. First one for training and next one for testing. Okay, first one for training and the next one for testing. And the number of attributes, or sorry, number of records to split for training set and testing set may vary. It depends upon the problem or depends upon the algorithm that you are using. Okay, so normally when you attend some session, you will get to know about what is the classification, what is training set, testing set. You will hear the terms, but I just want to make you understand how these terms are actually used, what is the purpose of each variable or the terminology used here. Okay, so if you want to divide the data set into training set and testing set, you have to identify the right ratio. Normally people will have 50-50 or 70-30 or 60-40. In the sense, 60% of the records will be used for training and 40 for testing. Or in some cases, if you need explicit training, you have 70% of the records for training and 30 for testing. Or sometimes 80 will be used for training and only 20% can be used for testing. That depends. And again, if you want to pursue a research, how to choose or how to split the data set into training and testing, and how to sample, how to split the samples for each subset can also be a research problem. So even it's a very big area. People may think that it's a small task. We are dividing the data set into two, that's it. Yes, but while practically you are experimenting, the way in which you split your data set into training set and testing set accounts very much. Because if you classify, that means if you split it into wrong subsets, obviously the final results would also be wrong. Okay, it's very crucial in classification. And in test data set also, you give the inputs. You don't have the final decision attribute. The objective is to find the decision attribute. And for the testing inputs, you have the feature vectors extracted. You apply to this model and the expected label of this is uptime. Okay, so this is another example. Just have this, no need of explaining. You have a subset of images. From the training set image features are extracted. The training labels are known, so it is also fed to the training process and the model is learned. Now the model is ready. Yes, next you are giving a new image whose label is unknown and we want to find. From this image features are extracted and using the learned model, the class label of this is predicted. Okay, and in general, mathematically representing any machine learning framework will have this y equal to f of x, where x is your image feature or any feature. If it is a text, you can have text feature, and you apply some function for the given input and you get the output. In the example where you have this is your input, you apply the function which is calculated in this learned model and you get this is an apple as a prediction. Okay, the same is represented in this framework. In any machine learning framework, this is the basic idea. And the prediction function differs. Okay, it depends on the algorithm or technique that you are using. Okay, training I have already discussed. So normally the main objective of training will be to minimize the error, prediction error. To minimize the error, we have to train aggressively. Our training should be in such a way that accuracy is improved and error is reduced. Okay, for testing, apply a function f to a never before seen example and output the predicted value. Okay, a simple example which makes you understand what is classification, where you have some examples, which is the first table is your training set and second is your test set. In the first training set, you have 4 records, and this is your class attribute. Diagnosis is your class attribute, and you have 2 class labels for this attribute, malignant and benign. Suppose if it is a tumor, for a given patient, you have to identify that the tumor is malignant cancer or non-cancer, or here in this case, benign tumor or malignant tumor. So here you have only 2 class labels. It's a binary categorical attribute, or we call it as simply binary attribute. Okay, this should be given to the algorithm and it will be trained, and the rules will be generated. How the rules will be? Okay, if tumor size equal to 5 and average area equal to 20, average density is this, it can be categorized as malignant. Similarly, you have another record for malignant, where you have if number of tumors equal to 2 and average area equal to 30, it can be malignant. Likewise, you have some set of rules for categorizing into different class labels. Okay, and here new records from your testing set comes. For example, a new patient comes into the hospital with the patient ID and he has 4 tumors, average area is 16 and density is this. What is his diagnosis? Either malignant or benign. We have to classify. This has to be done using the model that is being trained, and that is rule set that is being obtained. Okay, so this process is called as classification. Okay. Okay, and there are many classification algorithms. This list is only few of the algorithms, and we are going to see support vector machines. I will just give a brief introduction about SVM, shortly called as SVM, and we'll go into Python code. Okay, so without understanding what is SVM, you may not understand the code. That's why. So SVM is a basic, common and simple and efficient classification algorithm which are commonly used in any research. Even if you have today's world, we have thousands of classification algorithms actually. Every day, new algorithms, new classification algorithms are proposed for different problems. But among them, SVM still stands as the simple and efficient method. Okay, it maximizes. So here the problem is this. Okay, you have 2 set of class labels in a given problem. You want to distinguish between these 2 labels, these 2 classes. That means you want to classify them based on some properties. That means you have to write the function f which classifies these 2 groups. Okay, that is the main purpose of classification here. See this example. I'll just erase this ink so that you can clearly identify. Now your purpose is to draw a straight line or a function contributing this line which separates the 2 classes, 2 set of class labels in the given data set. Okay, this is called as the straight line separator, line separator. In support vector machine, you have to identify these support vectors. Actually, this is the separator. The middle line is the separator, and on both sides you have 2 lines. Yes, can you see these 2 lines? These 2 lines represent the margin. They are called as support vectors. That means the vectors which supports the process of classification. Actually, this is the linear separator, linear line which separates the 2 classes. And this is the margin. That means if some records enter into this range, they can be classified as class A or class B. And we have to maximize the margin in such a way that both class labels are segregated. And SVMs maximize the margin around the separating hyperplane. Actually, this middle line will be called as separating hyperplane. Okay, and the decision function is fully specified by a subset of training examples. And we have to specify the subset of examples for training and separate samples for testing. It's a quadratic programming problem, and it's common method which is used. Okay, so if your margin is narrower, you can miss out some samples. That means you can misclassify. To avoid misclassification, the margin should be broader. Okay, the margin should be broader. See here, you have to find the linear function to separate the 2 set of classes. This is the middle hyperplane which separates the two sets of classes. This green round circle represents one class label A. For example, benign tumor. And for this, this is malignant tumor. You have to, the samples are distributed like this. You have to separate, you have to draw a straight line which separates these two samples. But when you draw the line here, see this sample belonging to actually A class is present in this B class. Yes, but if you draw line here, it would misclassify because all the samples above this line will be one class and below this line will be categorized as another class. If the line is drawn here, it will be misclassified. Okay, so but some percentage of misclassification will be there in some problems. We cannot avoid that. But obviously, we'll try to maximize the accuracy. In the sense, we'll try to reduce the misclassification. You have to find this function SGN which minimizes the error. F of x equal to sine of, this is x and this is y. Y is nothing but here f of x. Okay. Okay, again you have many mathematical concepts involved here, but for now we'll skip those things because you can't understand all these things in detail. We'll see how it can be implemented in Python. Okay, so the distance between these vectors, everything can be seen. I will share you the slide. You can refer, and if you have any doubt, you can later on ask me. Okay, so, but the main idea is this. Okay, you have to find this straight line equation f of x. Okay, so which separates the two sets of classes. This problem is only for binary attribute. Okay, where you have only two class labels. If you have multiple class labels, then it is little bit different. You have to use some other method. Okay. Okay, this linear support vector machine. Actually, I have many things to say here, but for now, I'm skipping this and we'll go to the methods for Python coding. Okay, so we have to find the margin. Rho is the bit of separation between the two support vector of the classes. See, for example, here, and hyperplane is given by this equation wx plus b. Okay, our objective is to find the values for the variables w and b. X is our input variable. The values for w and b has to be identified, and hyperplane separating this line will be wx plus b. So this is the straight line. Okay, now you have to find the support vectors of this hyperplane. This if you have two class labels, this label will be equation under equation wx plus b equal to -1, and the next margin on the other side of the class you have wx plus b equal to 1. If this is satisfied, you have to categorize the testing sample as class A here, for example, and class B. If it is -1, it is class B, and if it is +1, it is class A. Okay, so this is the support vector. These are the support vectors. Our objective is to find W and B. Okay, so actually for this we are going to iteratively perform. In this case, we have to minimize the distance. Okay, minimize the distance. Here we assume that the distance from this hyperplane to this support vector is 1, and also here also it is 1. So totally the distance between two support vectors are actually 2. That is why Wt of xa minus xb equal to 2. Here 1, here 1. So 2. And the margin equal to 2 by normalized form of this weight. Okay, don't go deep into this. You can go deeper if you need. Okay. Okay, mathematically we have to find W and B such that this margin is maximized. Okay, and where Wxi plus B greater than or equal to 1, if that Yi equal to 1, and if Yi equal to -1, that means for another class label B, you have this. Okay. Okay, and sometimes you will have non-linear SVMs where you cannot draw straight lines to separate the class samples. How to do that? For that case, you need non-linear SVMs. That means another advanced versions of SVMs. Okay, so it's too hard to differentiate for these cases. For these kind of cases, how will you draw straight line? The samples are on the straight line, x value equal to 0. How will you draw line? It's impossible, right? It's not impossible. It is little bit hard. How to draw? Okay, so you have to change your functions. Okay. And before going into that algorithm, I just want you to know how classification algorithm can be evaluated. Okay, first, whenever you run any classification algorithm in any tool, it may be R or Python or MATLAB or any tool, or even if you write coding, there are some measures to evaluate how effectively it classifies. The main important measure is you will be having confusion matrix as the output. Okay, confusion matrix is nothing but a matrix which has two rows and columns. In the row you have true class labels, and in the column you have predicted class. Okay, where you have true positive, true negative, false positive and false negative, which was represented by these abbreviations. Okay, if actually imagine for the previous case, a patient can have either benign tumor or malignant tumor. Okay, so actually for a given patient, the type of tumor is yes, okay, here in this example it is given as yes or no. So you can have lone grant. Okay, lone grant is yes and here it is no. Okay, if actually for the given sample the lone grant equal to yes, and if your algorithm predicts, okay, so in column you have predicted class. If the algorithm actually predicts it to be yes, it is actually yes, and your algorithm also predicts loan can be granted, then it is true positive. Okay, on other case false negative means actually it is loan grant can be yes, but your algorithm predicts it to be no, then that is said to be false negative. True value is falsely identified as negative, that is why it is called as false negative. And another case, loan grant equal to no, that means for a particular customer grant should not be given, but your algorithm predicts it as yes, that is false positive. Falsely it is predicting it as yes positive. And true negative means it is actually no grant and your algorithm also predicts no grant, so it's true negative. And the main formula used to evaluate accuracy classification algorithm is classification accuracy, which is nothing but total number of samples in your testing set is the denominator. Out of the total number of sample sets, how many number of samples have been classified correctly. Okay, so for example, out of 8 samples, 6 samples are correctly classified and 2 samples are misclassified. That means either in this case, what are misclassification? This one and this is misclassification, whereas this are classified properly. Okay, so in denominator you will have all the number of samples. So A plus B plus C plus D, or total number of samples will be equal to the denominator. Okay, so denominator will have total number of documents, and A plus D represents the samples which are classified correctly as yes and correctly as no. Okay, so out of which, for example, if you have 6 samples correctly classified, 6 by 8 will be your classification accuracy. In some journal papers, if you refer, they will give classification error percentage. Okay, that means if accuracy is 80%, obviously the error is 100 minus 80, you will get 20%. Okay, so some papers will use the measure as accuracy and some will use it as error. So you have to be very clear in which measure you are using, right? And this matrix is called as confusion matrix, which confuses us. Yes. Okay. And these are other measures which are used to classify algorithm. Why I'm saying this is when you refer any journal paper which uses classification or anything, any machine learning algorithm or text classification, any problem, they will use these common measures: classification accuracy, precision, recall, F1 score, geometric mean. These are the common measures. Okay, precision is actually used in information retrieval, where you have this formula. It focuses on percentage of examples that have been classified positive examples that are actually positive. Okay, so this formula, TP by TP plus false positive. So TP by TP plus false positive. That means it represents the total number of samples which are predicted. Yes, yes. or in the denominator, and in the numerator you have actually the true positives. It means the number of samples which are correctly classified as positives divided by the total number of samples which have positive values. That is said to be precision. The higher the precision, the lower the false positives. When your precision is higher, why? Because false positive is in the denominator. If it is higher, obviously it will be lower, inversely proportional. And in recall, you have true positive by true positive plus false negative. It is nothing but true positive by true positive plus false negative. Originally, it is true, okay, but your algorithm predicts it as true or false. That will be in denominator, and numerator you have actually the true positive cases. And F1 is the weighted average of precision and recall. Yes, these are the common measures that you are using. Okay, and one more thing, I just want to explain you this term cross validation, because in Python code also you will be evaluating all those things in the example that we are seeing. That's why I am explaining these measures. Okay, cross validation is another process where after testing, when you perform testing, you will have the number of samples correctly classified and wrong misclassified. You will call that accuracy as test accuracy, testing accuracy. Normally, you will report that, okay, in any project report or journal paper, you can see the word accuracy means it is testing accuracy. After that, to further emphasize that the algorithm is more stronger, you have to perform cross validation. Okay, cross validation accuracy is also expected because when you write papers to some journals, they will some reviewers, some standard peer reviewed journals will ask you for to perform cross validation, because testing can also be sometimes wrong. If you choose the wrong number of samples or wrong samples for the testing set, obviously your testing will also be wrong. That means it may not be that much accurate. To evaluate or to validate an algorithm more accurately, you have to perform cross validation. Okay, how it's done is you have to split your data set into k subsets. So normally you call it as k-fold cross validation. K-fold means how many subsets you are going to divide. That is represented by k. Okay, and the data is divided into k subsets of equal size, and each subset in turn is used for testing and the remainder for training. If you use the same set of samples for training and testing, obviously how many times you run the example, you will get the same result. To avoid that, in cross validation, what we are going, it is nothing but cross checking. When we do something, we cross check again with the different cases, test cases, right? The same case here. See how it is done. Imagine this is your data set. Now you divide your data set into 10 subsets like this. Okay. Now imagine out of 10, you are going to choose one subset for testing and another for and remaining for training. So what you are doing in the first iteration, you choose first subset for testing and remaining 2 to 10 subsets for training. Okay. You measure the accuracy. For example, if you are running this, you obtain 90% accuracy, for example. Okay. Next fold, this is called as first fold. In the next fold, what you are doing, you are changing the testing set and the training set. You have divided into 10 subsets, right? The second subset is now chosen as the testing set, and the remaining 1 and 3 to 10 subsets are chosen for training. So if you train this using this subset and test with this second subset, for example, you now get 91% accuracy. And in third fold, you use third one as the testing set and remaining ones for training. You measure the accuracy. Likewise, you test with different subsets. Okay, so this, and you take average of the accuracies measured over all the 10 folds. That is called as 10-fold cross validation. Normally, it is k-fold cross validation. Here, I am demonstrating you for k equal to 10. Okay, the final performance is their average performance. Okay, normally people will go for 5-fold cross validation or 10-fold cross validation. is enough. Sometimes if it is large data set, you can go for 20-fold cross validation. Normally 5 or 10, these are the optimal values for K. Okay, so is it clear? Yes, ma'am. Yes, can anybody?
Yes, madam.
Yes, ma'am. Am I going fast or slow? Is it okay?
Madam, some a little bit fast, madam.
Fast. Okay, sir. So in which slide or which concept I need to explain you again, sir?
Previous slide, madam. Can you explain previous slide, madam?
This slide, sir?
Yes, madam. The starting, madam. Yes, madam.
Okay, sir.
Yeah.
Cross validation is to cross check whether your algorithm has performed accurately or not. Okay, whether it has classified accurately. For example, you have different algorithms. First, you are choosing SVM. You are going to check how accurately your SVM has classified. Next, you have another algorithm, naive Bayes. Next, you have another algorithm, decision tree. These are different classification algorithms. Now you want to evaluate which algorithm has what accuracy, classification accuracy, and you have to choose the best classification algorithm, for example. Okay, when you perform training, later you will test your data set. You will provide test set for your algorithm and check how accurately your classification algorithm has classified. Okay, even after testing, you cannot guarantee the testing accurate result. That means it can also sometimes go wrong. So to ensure that, again, we are going for cross validation, where I have already told you, if you choose wrong samples for training set and testing set, the entire accuracy may be wrong. To avoid that, we are testing with different subsets for training and testing every time, and we are averaging the result. Okay, so for that we have cross validation. First, you are going to split your data set. This is an example where if your data set has 10 records, for example, you are dividing it into 10 subsets. Okay, now here you assume 100 records, and in the first subset you have 10 records, second subset 10, third 10. First I will erase all those things. Okay, so this has 10 records, this has 10 records, each will have equal number of records. Okay, after this we are going to change the subsets we are going to evaluate. This is again done to cross check whether we are doing it accurately, we are classifying accurately. Okay, first what we are doing, the first subset with first set of 10 records, for example 1 to 10 records are chosen for testing, and records from 11 to 100 are chosen for training. So 11 to 100 record will be used for training, model will be created, rule set will be created, and then the samples in the testing set will be evaluated. The class labels of these records will be deleted. Okay, for checking it will be deleted, and we are going to evaluate using our algorithm. For example, SVM. And out of this 10 records, suppose if the algorithm classifies 8 records correctly, okay, loan grant equal to yes, loan grant equal to no. Okay, so out of which if it classifies 8 records correctly, then it is said to have 80% accuracy. Okay, next you change the testing set. In classification, you have a common problem called overfitting, where if you have two class labels and the training samples have all the class labels as A. For example, you have class A and B. If all the samples chosen in training samples are belonging to class A, when you give class B record as a test set, you may not find the right subset. You cannot find the model. Yes, because you don't supply the class label for the testing set. So that
Hello?
is the, yes sir.
I write down some question in the chat box.
Sorry sir.
I write down some questions in the chat box.
Sorry sir, I don't get you.
Now I am audible, ma'am?
Yes sir, audible.
Ma'am, if the more number of data set will be there, then the time complexity will be very less in that condition.
So
In
you
the
have,
tenfold or in the different type of cross vegetation, if I am applying to.
Sir, in tenfold cross validation, sir, I'm not getting you clearly, sir.
If I am having a tenfold cross validation,
Okay,
and
sir.
my data set is very large, then what about its complexity, ma'am? Because if the more number of testing sets will be there, then the time complexity will definitely increase.
Yes, sir, definitely increased.
Then what we can do
Sir,
to
okay,
come down the
sir.
time complexity? And another question is, what will be the ratio of training and testing data set?
Okay, sir. As I have initially told, the ratio for training and testing set can vary depending on the problem. For example, if your data set has complex structure and complex label organization, you can have many samples for training and less samples for testing. For example, if you have 5 class labels, obviously you need more samples for training. So it can be 80-20. Or if you have partial equal number of samples in your original data set, you can have 50-50 or mostly 60-40. If you have more number of labels and there are many conditions to separate between the labels, you can have more samples in training set and less samples for testing set. And there is no strict guideline to set the ratio, sir. Actually, that depends upon the problem and the user. For finding the best ratio, you have to trial your experiments. You have to run with different ratio and find the best ratio which suits your problem. Even in any journal paper, they will specify only the final ratio sometimes, because it is not guaranteed and it is not common to all problems. It depends upon the problem. You have to choose. You have to make trials with different ratios and find out the best suited for your problem. And I have already told you, you can pursue your research on dividing the ratio itself. Yes, sir, did I answer you for the second question?
Yes, ma'am.
Yes, sir. For the first one, for the first question.
My question is that another is there any similarity similar technique is there to get the more accurate result?
Sir, more accurate ratio, sir?
Yeah, more accurate results, because why we are applying the cross validation to improve the accuracy as such.
Sir, cross validation is not used to improve the accuracy. It is used to check or validate whether your algorithm has accurately classified or not.
Yes, ma'am, that's correct. Is there any another technique, similar techniques instead of cross validation?
Okay, sir. So actually there are here different types of cross validation. You can use any types of stratified cross validation, k-fold cross validation, and in validation itself, there are different types and you can choose any type, sir. Yeah, while showing Python code, I will show one stratified cross validation, sir. And I don't think there are any other methods. Normally people will do this validation. Okay, sir. And for the first question, if your data set is too large and if you have more samples for training and testing, there is no other option. You have to select the samples. If you have, for example, 50 lakh records, you cannot use all the 50 lakh records for training the algorithm. For that, you have to choose only the samples. Out of 50 lakhs, for training your algorithm and to reduce complexity, you can choose, for example, 1,000 records for training and also for testing. So that selecting of those 1,000 samples out of 50 lakh records depends on you, how you are choosing. And you can use some methods for those samples also, sir. And there are methods. You have many machine learning algorithms to select the samples if your data set contains large number of records. Did I answer you, sir?
Yes, ma'am. Thank you, ma'am.
Okay, sir.
Actually, my research is going on in the same field. I'm working on the leaf disease identification and their results and their satisfaction results, so that whenever we are planting anything and the diseases come out from the leaf, then from since sowing to the harvesting, I need to be monitor all the diseases which can be often there on the leaf.
Okay, sir. Okay. So for any kind of problem, normally the data set will be large nowadays. If
Actually,
you have,
I stuck somewhere else. I didn't finding any data set, reliable data set on your on the internet. So is there any source? Can you suggest me?
For data set, sir, for getting data set, you can use UCI machine learning repository. UCI machine learning repository. Just you search in Google for UCI repository. University California Irvine, that is the expansion. And in this repository, you can have a list of hundreds of data sets of different applications. You can choose your applications. This is one of the common repositories, and there are many more repositories. If you have any doubt after the session, you just mail me, sir. I can clarify your doubts if I'm able to do that.
Thank you. Thank you very much.
Okay, sir. And this is how classification, cross-validation have to be performed. Okay, now let us go into the Python code. Okay, I think we have consumed more time on this, but do you have the Word document Python code that is being shared to you? Or even if you don't have, I will share you now and you can all refer. Sir, is the Python code visible to you all? Now the Word document, support vector classifier.
Yes, ma'am.
Yes, sir. Okay. Okay. So now we'll see how it can be implemented in Python. And first I will show you the results. Okay. So first let us explain the program and then go for, you can just copy the code that I have sent you and paste in Colab or any online compiler. Normally here you need many inbuilt packages. So when you use normal Python compiler, it won't run because you need Pandas, Skylern, sklearn and all that is not available in other compilers. You can run this program in Colab. So because in Colab you have all the library functions already installed. Okay. So the first thing we are doing is, the program is very simple. See here, just within one page, I have enlarged the size. Otherwise, it will be only half page code to perform classification. Okay. First, you have in Python, when you are using inbuilt functions, most of you know how to run Python or Python coding. Yes. I assume, yes, sir?
Yes, ma'am.
Okay. I assume that you know the basics of Python and go with this. And if at any time you have any doubt, please stop me and ask. Okay. And here Pandas is used. Pandas is an inbuilt module which is present in Python to support data analytics operation. Okay. So you can import that from Pandas. This is the basic syntax, right? From module or package, import the particular module. Here we are going to provide the iris data set. As Sar has asked, I have downloaded a data set from UCI repository where it has iris data set. Iris is the common data set which is used for classification. You can choose any data set. Okay, for demonstration, this is very simple with only 5 attributes and 150 records. Okay, so we have chosen this attribute. Okay, so here from Pandas import read CSV. Here we are going to read the iris dataset in the form of CSV file. So CSV is an inbuilt module which we have to import, and this read CSV module is present in Pandas package. So from Pandas import read CSV, and next we are going to import train test split module from this sklearn. Sklearn is nothing but scikit learn. Initially it was called as scikit, SCIKIT. Now it is sklearn dot model selection. We are going to choose the model or select the model and divide our data set into training set and testing set. What is the purpose of this module is, it actually splits your data set into train set and test set. And here we can see below what is the training set size and testing set size. If you set the size to 0.20, it means 20% of the records will be for testing and remaining 80 for training. And again, there is another problem. Out of 80-20, which 80 will be chosen as training and which 20 will be for testing? That is again a major problem. To ensure that only we are going cross-validation at the end. Okay, but initially, while splitting this data set, this will be done at random. Okay, randomly 20 samples will be for training, sorry, for testing and 80 for training. Or you can change the ratio here. If it is 0.3, 30 for testing and 70 for training. Okay, this will split your data set into train set and testing set. Next, this classification report module contains the classification measures. Okay, you have the reports displayed as F1 measure, precision recall, all the reports out of your classification can be imported here from metrics. Okay, sklearn.metrics is the module which contains all the performance measures. Okay, for classification, clustering, for all the operations. And you have confusion matrix also here. So you can import this module also. And import accuracy score, this imports your classification accuracy value. And the model which we are going to use here is support vector machine. Here you don't worry about the internal processing operations of SVM, because everything will be handled by the compiler itself. Already in pandas, everything is inbuilt. You just need to call that function. Okay, but the processing, providing input is the only thing that we have to do here. Okay, SVC stands for support vector classifier and sklearn.svm. So in the sklearn module, you have this SVM module. Okay, first what we are going to do, you have to specify the URL of your data set. This can be any direct URL, or you can specify the URL here also. Okay, so data set equal to read underscore CSV is the inbuilt function which reads data from the URL. Normally you will be confused with how you have your inputs in CSV file or Excel file. Now you want to use that in your Python program. Many people will be stuck up with this. Why I'm saying this is, ma'am, Rajalakshmi ma'am, up to what time I can take the session? Hello, ma'am. Okay, I'm continuing, and if it's time, just let me know. Okay, so that I can accordingly adjust. Okay, so read CSV is the function which is already imported, module imported. So you can directly call the function which reads inputs from your CSV and load that into a data set. Okay, so here data set is a variable. In Python, you already know you need not specify the data type. Depending on the values that you are providing at the right hand side, the data type will be automatically detected. Yes, so read CSV will read you, but again this URL can be initially specified within double quotation. Here they have specified this iris.csv, or if you have the data set directly loaded in a particular location also, you can specify. Okay, next, names equal to, there you in the data set you don't have the header. In that you have 5 attributes. Sepal length, iris is actually a flower. Okay, normally a flower will have sepal length, sepal width, petal width, and this class, this is the final last one is the class attribute. Okay, so when you click on the link, you can have the view of iris data set. Okay, so where it has 150 records, sepal length, all these are numeric attributes, 1.2, 1.3, 3, 4.5. And this flower has 3 class attributes. Okay, iris setosa, iris versicolor, and iris virginica. These are the 3 class labels for this iris flower. You have to categorize the flower based on the these 4 attributes. Depending on the sepal length width or petal length width, you have to identify which category among the 3 categories the particular flower belongs to. Okay, and the header names can be given in a variable. Initially, it can be stored. Okay, and data set equal to read CSV of URL, or sometimes you can specify the URL here itself within double quotation. or you can store it in a variable and that variable can be given here. And names equal to is an inbuilt function which holds the header for your data set. Okay, now you have extracted the data from the CSV file into your data set in your Python program. Next, what you have to do, you have to split your data set into training set, testing set, and validation set. Okay, so here array equal to data set dot values. In data set, now you have two things, values and names. Yes, data, now you are creating an array. Okay, array or here list. Yes, in the list you have only the values extracted. Now all the values of these 5 attributes will be stored. Okay, and you are going to extract. So what does this mean? Array of colon comma 0 to 4. From 0 to 4, before colon you don't have anything. So that means all rows have to be selected. After this colon you have comma colon 4. That means you have 5 attributes. Out of that you have to choose only 4 attributes. That means other than class attribute. This is array of 0, array of 1, array of 2, array of 3. 4 means 4 will be excluded. So index 0 to 3 will be chosen. So records from these 4 attributes will be loaded into the variable X. And the 4th index, array of 4 will contain this class attribute. So that index alone will be loaded into Y. What is the purpose of actually, or what is our classification? What will do? Y equal to f of x. Yes, this is what we normally try to do. Yes, x is your input variable. Based on these 4 attributes, you are going to predict the class label of the record, which is nothing but the 5th attribute. Okay, initially in the given data set, you have all the class attributes. For testing an algorithm, you have to delete the class label of the testing set and try to find how accurately your algorithm evaluates. Okay, so this is what is normally done. And again, you are calling the function train test split. Here it will be splitted. How it is split? X, Y. Okay, so X will be one subset, Y will be another subset which contains the class labels. Test size equal to 0.20. So 20% records will be taken here, and random state equal to 1. So this is used to shuffle the data samples. Okay, this is optional. You can have any value or just leave that. And here output of this training test split will be 4 values actually. Okay, X train and Y train. That means for training set, the 4 attributes, first 4 attributes and its corresponding labels. For the X attributes for validation, that means for testing, you have X and the corresponding Y. Okay, these 4 set of values will be separately extracted from the training test. Okay, so now you have the test splitted. Is it clear? If you have any doubt, please let me know. Now you have to apply, sir.
No doubt, madam. No doubts. No doubts.
Okay, sir. Okay, sir.
Hello.
Next, yes, sir.
Please don't mind, ma'am. I have a doubt. Suppose
Yes,
if I want to detect the human body,
yes, sir.
how I can differ the variables, ma'am, here?
So what
For
are
the data
based on what factors you have to detect the human body?
like activity, ma'am, misbehavior.
Misbehavior in the sense, sir?
Example, traffic.
Okay.
In the traffic, they are doing misbehaviors like accident or whatever it may be.
Okay, sir. So for that, you will provide some input, right? So what are
Yes,
the
ma'am.
inputs normally? Number of vehicles which are very close, or you have even sometimes you have the images. Suppose if
Yes,
you are
ma'am.
going, sir, you have input as image, you have to separate the image features. That is why in the previous Trump example and all, I have shown 2 different images where
Yes.
pixel by pixel you have to separate, and on that region if it is closely dense, and image processing has different parameters, sir, many parameters, but anyhow whatever may be the data set, text or image or anything, it will be stored as variables. Yes, sir. Attributes and their corresponding values. So you have to find the rules or set the condition rules for each attributes. If x equal to this and this, between this value, and y attribute equal to this and this, you can classify them as more traffic, or they have come with high speed likewise. So
Okay.
depending on the problem, you have to extract the right features and set the range of acceptable values for those variables, sir. And if these conditions are satisfied, you can classify as class B or class A, or depends, sir.
Thank you very much.
Okay, sir. And next is your actual algorithm implementation. SVC is an inbuilt function which you have already imported. You can directly call the function now. Model equal to SVCF equal to odd. Actually, in the SVM algorithm, you have sine function, right? So here they have implemented as gamma function. You have different versions there. So just don't bother about that for now. Gamma equal to auto. Now the model is created. Model is nothing but here the rules. Yes, I have told you for the traffic example SAR has given now. If number of persons in this area is greater than 50 and the number of vehicles equal to this and the road size equal to this, you can specify traffic equal to high, and another range if the road size, number of people and all those things is within another range, traffic equal to medium. So likewise you can classify. That set of rules are being constructed by using this SVC algorithm here. That is inbuilt here, so don't worry about that. And the set of rules will be output here. Now again what you have to do, this training samples and Y train have to be given as, here the model is constructed and now it is being trained. Now the training set is given as input for this model and it is being fit. These are inbuilt functions. Model.fit is the inbuilt function for which you are supplying your training set, where X train is your first 4 attributes and Y train is the class attribute. And now you are predicting. Okay, predicting what you are predicting, model.predict of X validation. For the training set, you are predicting. Okay, so you are predicting whether all are accurately classified. Here you have only training. Okay, so next what you are going to do, it is actually training accuracy is only calculated in this program. For testing accuracy, you have to predict this instead of X validation, you have to give Y. Okay, Y test and all those things. Next, predictions equal to model.predict. How you are going to accurately evaluate this algorithm has classified. Again, you have inbuilt functions, predict accuracy score, confusion matrix, classification report. For accuracy score, you need Y validation and the predictions. Predictions is the variable which contains the output of your prediction. So from this, you can get the classification accuracy. Next, this statement will give you the confusion matrix printer. And next gives you the classification report, which shows precision and recall. Now I will run this in the Colab. You can see how the output is. Okay. Sir, is the screen visible now? Is the Colab screen visible?
Yes, ma'am. Yes.
Yes, sir. So I have already opened the Colab screen and just give new notebook. Okay, a new screen will be opened where you can copy your program. Just copy the same program that is shared with you and paste it. So here you can okay, you can just copy it and run. Can you see the output here? Or if you have run the same program in your system also, you can get the same output. So what is the first one? 0.9667. Can anybody tell what is this value? We have printed 3 sets of values, right? What is the first value?
Accuracy. Accuracy.
Yes, ma'am. It is classification accuracy, which we have predicted. So how it is calculated? What are the inputs for this accuracy score? Y validation and predictions. The predictions is the predicted output and Y validation is your actual class label. Okay, so the original class label and the predicted class labels are compared and the accuracy is evaluated here. Okay, the next is your matrix. What matrix is this? What
Confusion matrix?
Confusion matrix. Okay. So what do you infer from this confusion matrix? 11 0 0 0 12 1 0 0 6. Can anybody identify? Yes, ma'am.
Predicted value and class result, ma'am.
Yes,
actual result.
Ma'am, actually now can you see the notepad, iris dataset notepad?
Yes, ma'am.
Okay. This is actually your original data set where the first 4 attributes are the sepal length width and the final last attribute is your class attribute with 3 values. You have iris setosa, iris versicolor and some samples for virginica. You have 50 samples each originally. Okay, now here you take iris setosa, next virginica, next versicolor. And in the Y label also. Here, for example, setosa, this 11 gives you, out of the total records, 11 records have originally setosa and your algorithm has correctly predicted as setosa. Okay, and 0 records are wrongly predicted as versicolor and virginica. And in the second record, for example, second row represents virginica, 0 records are classified as setosa. Okay, so 12 records are correctly classified as virginica and 1 record is wrongly classified as versicolor. Okay, similarly, if the third row and column represents versicolor, 0 samples are classified into other 2 samples and 6 samples which are originally versicolor are correctly classified as versicolor. So now do you understand how this confusion matrix is calculated? Okay, so this is confusion matrix and in the classification report you have precision, recall, F1 score and support. Okay, so here you have all those things. That is why in the slide I have explained you the formula. This is iris setosa. For iris setosa, 100% precision. That means 100, 0 to 1 is scaled as 100, 0 to 100. Okay, 1 means all the records which are iris setosa, all are correctly classified. So precision will be 1. That means 100% it is precise, accurate. Okay, recall is also 1. F1 score is 1 and support the 4th value. It is nothing but the number of records. Just relate with the first row in your confusion matrix. Okay, and in the second row, iris versicolor, you have, okay, so precision is 1. Okay, it is correctly classified and recall is 0.02. Go to the formula and check how it is misclassified because one sample is misclassified. Originally, versicolor sample is misclassified as virginica. That is why it is 0.92. And F1 score is 0.96 again. And iris virginica, so all the samples are correctly classified here. But one sample which belongs here actually is misclassified here. So this deviation is there, 0.86 and 0.92. Okay, and here you have the accuracy, macro average, weighted average, or some other additional measures which you have. Okay, now is it clear to all how a machine learning algorithm can be run in Python? This is a simple example. You have many inbuilt algorithms implemented in Python. The only thing is that you have to import all these modules from the pandas package and load your data set. Next, after loading, you have to split your data set into training set and testing set, call the corresponding function, and finally evaluate the performance measures. Yes, ma'am? Okay, so the second program, here this example compares different classification algorithms. Okay, again, this is also very simple. You need not worry about how to implement this code for each algorithm. Everything is inbuilt. You just have to write a single statement for calling the function. Okay, after this, again, I want to run the second code. So I'm just copying and pasting this. Before, see the output, and then I will explain. See the output here. Here we have compared 6 methods, 6 classifiers. Linear regression, LDA stands for linear discriminant analysis. K nearest neighbor, classification and regression tree. Next naive bayes and SVM. Okay, we give input as one data set to all the methods, all 6 methods, and now we are able to see which method has produced which accuracy. Okay, let us see the program now. Just the same thing. We don't have any additional thing. As usual, import read CSV module from pandas. Here we have plotted. We have created box plot at the end, right? We have the box plot. So what you have to do, you have to import the required libraries for plotting. So pyplot is the inbuilt module which is present in matplotlib. Okay, in matplotlib module, you have supports for box plot, scatter plot, line plot. Okay, so now we are going to use this pyplot, import that. Next, train test, cross validation score. As I have already told you, we are performing stratified k-fold validation here. Again, all are cross validation, but the types differ based on how you are separating the samples in each fold or in each iteration, how you are selecting samples for each testing. Okay, so here stratified k sampling, I will explain you while coming down. And these are all classifiers. These are 6 classifiers available. First, import logistic regression. First classifier, it is present in sklearn.linear model. Next, decision tree classifier, KNN, all those methods are imported here. Next, as usual, you import your data set, specify the URL here, specify the header names, and load the CSV file into your data set. Next, extract the data set values, that means attributes 1 to 4, and store it in X. The last final class attribute is stored in Y. Okay, next it is being splitted. Here I have given 20. If you change the test size, again your accuracy, your results, everything will be varied because the input samples will be varied. Yes, so we should be careful in choosing the samples. That is why most of the learning algorithms, accuracy cannot be evaluated with just one run. So you have to run the algorithm with multiple runs. You have to execute them with different sets of inputs. For example, at least 30 times an algorithm should be run. And the average of the 30 iterations should be reported. Why I'm saying this is, I have used all the algorithms, almost all the classification algorithms for my research purpose. My research area is machine learning, data processing, and I have used classification algorithms, clustering, feature selection, and all those things I have used, and based on, and I have published many papers also, even in high impact factor journals. I have more than around 15 journal publications I have in the last 3 years itself. In all those papers, I have received many comments from the reviewers in Elsewhere, Springer, or anything. Mostly all the reviewers will expect you to provide cross validation at the end. If you are doing any classification after testing accuracy reported, you have to perform this validation. Only then they will accept you that it is right. Okay, and they will ask you for how to choose the, how did you choose the training testing ratio. Again, this will be the question asked. For that question, you have to answer whether you have chosen it randomly or you have tried with many ratios and find out that this is the best. Okay, now you have done this. Now the data set is split.
No doubt, sir.
Model is equal to this. Can anybody tell what we have done here? Models equal to, those who know Python can answer me. Yes, can anybody? Models equal to just an empty bracket is opened and closed. What does it represent?
Array list, I think.
Yes, sir. An empty list is created. Yes, models
Yes.
equal to empty list created. And next we have appended every model. We are implementing each model and appending the output of each model at the end of this models. Okay. So first logistic regression is applied. For this, these are the arguments that you have to supply. Just you can Google it and find the right syntax. Okay. And the result of this logistic regression is appended to this list. Next, linear LDA, that result is also appended. KNN result is appended at the end. So likewise, models will now contain at the end the classification results of all the 6 models. Next, you have to evaluate results names, again 2 empty lists, and for name comma model in models. Again, those who know Python should know how the for loop can be used. Yes, in models you can extract 2 loop variables, name comma model. This is stratified k-fold cross validation. So stratified validation is nothing but if you are splitting your data set into okay, now okay, can you see this slideshow? Can anybody answer? Is it visible?
Yes, ma'am.
Yes, sir.
Yes, ma'am.
Okay, sir. In the cross validation, for example, if you have 10 subsets and you have 2 class labels, for example, grant loan equal to yes and grant loan equal to no. For both training and testing, you have to choose the right equal number of class labels. That means equal proportion in both training set and testing set. For example, testing set, you have 10 records. Out of the 10, 5 should contain class label A and 5 should contain another class label B. That means yes and no. Similarly, you have 90 records for training. Among them, 45 should contain exactly grant loan equal to yes and remaining 45 for grant loan equal to no. Okay, so in both subsets, that means training set and testing set, the class labels should be equally divided. If you have 3 class labels and if you have 9, so 30 for class label 1 and 30 for class label 2 and 30 for class label 3. Okay, this is very much required because if you have many class labels and if you have chosen some samples with 1 class label, for example, out of 90 samples, out of 90 test training samples, you have chosen 50 samples for class label 1 itself. Obviously, you will miss out the samples for class label B. Yes, so that your model is wrong and again your testing will also go wrong, that much accurate. So you have to choose or give equal priorities to all the samples of class labels. That is why in stratified class sampling, you have priorities given to all the class labels equally. Okay, so our number of splits equal to 10. Here, that is again 10-fold cross validation. 10-fold is different, but here in stratified, all the samples have equal number in each subset. Okay, and random state equal to 1, shuffle equal to true. That means sample should be shuffled again. And k-fold is now generated and cross validation results equal to cross validation score is an inbuilt function for which you have to supply the model. Now the model is to be given as input, X train, Y train. Okay, so that means input variables and the class attribute, and we are specifying cross validation equal to k-fold, scoring equal to accuracy. Here you can have any measure, accuracy or precision or recall. Now if I need accuracy, I can specify the scoring measure, and the results is being stored in this CV results. And the next, results dot append of CV results. What happened? First you choose among 6 models, the list of models of 0 will contain the classification result of this logistic regression. First this model is chosen, cross validation is performed, and that result is stored in the CV results. sorry, results. Next, for next model is chosen. The next model is nothing but your LDA. This is cross-validated. The result is obtained. The result is appended again. And next, the names of the results is given. And you are printing the classifier name, their mean, and standard deviation, which is shown in your output, right? So what is your output? See here. So the classification accuracy, mean, and average, standard deviation, everything is displayed here. You can choose the measure. Okay. Next, if you want to compare the algorithms with the help of plotting, you can plot. Now we are going to use box plot. So pyplot dot box plot of all the results are stored in results variable, results comma labels equal to names. Okay, you can set the title of that, and pyplot dot show will display you the box plot like this. Okay, so this box plot where the x-axis represent all the methods and y-axis represents the accuracy measure. Okay, so this can anybody identify what does this represent? This is it runs for n number of iterations. Okay, that is pre-inbuilt set. So this is the average accuracy for LR. 0.96, for example, is the average accuracy, mean accuracy, and this is the standard deviation. It varies from 0.91 to 1, for example. And in LDA, the average is 1. Okay, it's mean, and minimum you have this. And for KNN, you have this average accuracy, and the box plot, it goes like this. Okay, likewise, you can have a plot of all the methods. Not only this, you can run many more algorithms just within a single line. Okay, so just a single line, you can call any machine learning algorithms in Python. It is very simple in Python. Okay, you can use classification algorithm, clustering algorithm, feature selection algorithm, or data pre-processing algorithms. My research area while doing PhD was to pre-process the data. It means to impute or to find the missing values in a data set. For that, I have used genetic algorithm, naive-Bayes algorithm, naive-Bayes classifier. So all the classifier algorithms I have used for my data set. And now again, I am working on this for medical data sets. I am trying to apply many of the machine learning algorithms for handling the problems in data sets, large data sets. So is it clear to all, or if you have any doubt, you can just unmute and ask me. Ma'am, can I close here, or you want, if you have time, I can go with some other contents.
Participants, if you have any question, do type in the chat box.
And in future, if you have any doubts regarding your machine learning algorithms or how to implement them in Python, you can just text me. This is my mail ID, which I have shown in the initial slide. This is my mail ID. You can text me, and I am very glad to help you if I can.
Hello, ma'am.
Yes, sir.
Ma'am, same thing. I am the research scholar.
Yes,
I'm
sir.
doing PhD in digital image processing,
Okay,
but
sir.
I want to detect the objects in the multiple in the sense it may be a human, or it may be the vehicle, or whatever it may be. Same method, it's going to write the code in the same manner, ma'am.
Yes, sir. Same. You have to provide different inputs. Here we are specifying the numerical values. For your problem, you are going to provide image as your input. Image
Yes,
can
ma'am.
be.
Yes, ma'am.
Yes, sir. That's the difference. The same, the algorithm implementation is the same.
Okay, but I have doubt here. Numerical is the input, but how we can give images the input here?
So images have to be given as input in the sense it will be automatically converted into numerical values. That means if you are giving an image, the pixel by pixel, the values are extracted and only those pixel values will be fed as input. That algorithm will take care, sir. If you are providing input, there are many inbuilt functions to extract those features from the given input images. In Python, in MATLAB, in R, all those programming languages, you have the inbuilt methods for those. So we just need to give inputs, that's it. And the features will be extracted from the images automatically.
Okay, okay. Thank you, ma'am. Thank you.
Okay, sir. Any other doubts?
Madam,
Yes, sir.
excuse me, madam. How to divide the sample from large set, madam? Is there any methods, madam?
Sir, dividing the samples from your large set, there is no strict rules or there is no proper standard established. You can use your own heuristic or your own logic, sir. It depends upon the problem normally.
Okay, madam.
But my suggestion is based on my experience, stratified sampling will be better. For example, if you have 3 class labels for your given problem, you choose equal number of samples from each sample. Okay, class A, class B, class C means if you have 150 samples to be chosen, choose 50 samples from class A, 50 from class B and class C. That would be better so that you can avoid the chances of other classes missing out in your training samples.
Okay, madam. One more question, madam. In
Yes,
SVM, in module, you are utilized only gamma, madam. Gamma in module
yes,
Python. Is there any other or only you need to apply the only you need to use the gamma, madam?
No, sir, there are many inbuilt functions. That means for processing that f of x, no, there are many functions and you have linear SVM, non-linear SVM, and there are different versions of SVM, sir. For different versions, you have different inbuilt functions. You can use those inbuilt functions, or if you are writing your Python code on your own, in the sense you are not going to use this inbuilt Python function. You are going to devise your own function. You can write your own logic for functions, sir. That's also possible.
Okay, madam. Okay, thank you very much, madam.
Okay.
Oh, madam, let me one, madam. Data set. How to get the data set, madam? That give me the upset name, madam. Brain tumor data, madam. I want a brain tumors data.
Sir, brain tumor data set is also available in UCI repository, sir. So let me show you, for example, sir, this is download. If you just give in, sir, is the screen visible now?
Madam, zoom it, madam. Can
Yes,
you zoom it, madam? Can you
Yes,
zoom,
sir?
madam? Zoom it, madam. Can you zoom?
Okay, sir. So just in Google type UCI repository. Just give UCI repository. This will be the first link, sir. This is a commonly used repository, and in the repository you have many data sets, sir. So here you have brain tumor data set also. At the top you can give brain tumor. You can specify the data sets, sir.
Yes, madam.
So all the data sets are visible here. So you can choose the data set that is required. You may view all data sets, click all data sets, and there are data sets separately given for classification, different machine learning operations. Based on this, you can choose the data sets. I think, I don't know in which category that brain tumor data set comes, but it is there, sir. I have seen that data set.
Yes, madam. Yes, madam.
For breast cancer, brain tumor, it will be categorized, sir, so you can find it very easily.
Okay, madam. Thank you, madam. Thank you.
Okay, sir.
Hello, ma'am. One more question.
Yes, sir.
Suppose
Yes,
some other people, they are used for data set. Suppose we can use that data set, ma'am. Is it problem? Any problems will come?
Sir, that means you are trying to use the data set that some people have used in other
Yes, ma'am.
papers, sir. So
Yes.
if that is the standard data set available in the common repositories, you can use, sir. Or otherwise, you cannot use those data set, because when you are writing a paper for a good journal, they will expect you to use only the referred benchmark data sets. They cannot accept
Yes,
you the
ma'am.
data set that you have collected on your own, because they may not know what is the actual distribution of the data set that you have collected. So it is not suggestible to use the data set that is being used by other persons in other journals. If they have used, and if you want to use the same data set, actually that should be already approved by the other people, sir.
Okay.
Once it is
Because
approved, yes, sir.
because this is related to research, ma'am. I want to prove that.
Okay, sir.
That's why the data sets I'm asking, ma'am.
Yes, sir. This is the common problem that any researcher face. And when I was doing research also, I was also facing the same problem. That I was also having the same doubt. How can I choose the data set? For that, you have to use the benchmark data set, sir. That is the best option. Or if you have data set of your own, you have to properly provide all the characteristics. You have to present the features explicitly in your paper, sir.
Okay.
You have done case study kind of thing.
Okay.
You can do, but with proper justification, you have to provide.
Thank you, ma'am.
Madam,
thank you, sir.
One question, madam. In Python,
Yes,
all the sets are available. Only
sir.
you are utilizing in Python code, madam. All the data sets are accepted, or only you CI data set, madam.
No, sir, no, sir. All the data sets are available. You can store your own data set
Not
in your
available, madam.
location, in your desktop. You can create your own data set in your desktop and give that link also. You can choose any data set, sir.
Okay, okay, thank you. Okay, madam, thank you.
Okay, sir. Any other doubts?
Thank you very much, ma'am. Thank you very much. Nice.
Thank you, sir. Did you all, I just want to get feedback. Did you get anything out of the session, or did you understand? Okay, because within this short time, I can share with you only the limited things. Yes, ma'am. Anybody have any doubt?
I hope there is no doubt from the participant side, ma'am. Thank you, ma'am. Thank you for giving such an in-depth explanation on machine learning concepts. Really learned a lot of new stuff, ma'am. I hope everyone has utilized this session. Once again, thank you, ma'am. Thank you for your excellent session. So this is Sabareshwar winding up the session. Hope we shall see in the next day, which is tomorrow. See you all tomorrow. Thank you. Thank you all.
Thank you, sir. Thank you all. Thank you for patient listening.
Thank you. Thank you. Thank you.
Thank you all.